The late 19th and early 20th centuries witnessed groundbreaking discoveries in physics, forever altering the course of human history. This era was marked by a fervent quest for knowledge, as scientists around the world delved into the mysteries of the natural world, laying the groundwork for what would become the atomic age. In 1896, Henri Becquerel, a French physicist, stumbled upon the phenomenon of radioactivity while investigating uranium salts. His serendipitous discovery was a pivotal moment, revealing that certain materials emitted invisible rays that could penetrate solid objects, a property that defied the conventional understanding of matter at the time. This discovery opened a Pandora's box of scientific inquiry, leading to a deeper understanding of the atom and its immense potential. Scientists were now eager to explore the enigmatic world of subatomic particles, driven by the promise of uncovering the fundamental building blocks of the universe. Building upon Becquerel's work, Marie Curie and her husband Pierre Curie conducted meticulous research on radioactivity, coining the term and isolating radioactive elements like polonium and radium. Their tireless efforts and innovative techniques not only advanced the field of physics, but also introduced new methods for studying radioactive substances. Their pioneering work not only earned them Nobel Prizes, but also laid the foundation for a new era of scientific exploration, the atomic age. The recognition they received highlighted the significance of their contributions and inspired a generation of scientists to further investigate the properties and potential applications of radioactive materials. The discovery of nuclear fission in 1938 by German scientists Otto Hahn and Fritz Strassmann marked a pivotal moment in the history of nuclear technology. Their experiments demonstrated that splitting the nucleus of an atom could release an enormous amount of energy, a revelation that would have profound implications for both science and society. Fission, the process of splitting an atom's nucleus to release tremendous energy, held both promise and peril. On one hand, it offered the potential for revolutionary advancements in energy production, providing a nearly limitless source of power. On the other hand, it posed the threat of unprecedented destruction if harnessed for military purposes. The scientific community quickly realized the potential implications of this breakthrough, particularly in the midst of a world war. As nations raced to unlock the secrets of nuclear fission, the prospect of creating a weapon of unparalleled destructive power became a driving force behind many research efforts. The possibility of harnessing this energy for destructive purposes became a terrifying reality, casting a long shadow over the future. The atomic age had dawned, bringing with it both the hope of scientific progress and the fear of annihilation, forever changing the course of human history. As World War II engulfed the globe, the specter of nuclear weapons loomed large. The world was already witnessing unprecedented levels of destruction and loss of life, but the potential for even greater devastation was on the horizon. The United States, fearing that Nazi Germany was developing atomic bombs, initiated the Manhattan Project in 1939. This monumental effort was driven by the urgent need to ensure that the Allies would not fall behind in the race for nuclear supremacy. This top-secret research and development undertaking brought together some of the brightest scientific minds of the time, including physicists like J. Robert Oppenheimer and Enrico Fermi. These scientists, many of whom had fled from Europe to escape the war, were now united in a common cause. Working tirelessly in secret laboratories across the country, the scientists involved in the Manhattan Project raced against time to unlock the secrets of nuclear fission. Their work was shrouded in secrecy, with even many of the workers unaware of the true nature of their mission. The culmination of their efforts was the successful detonation of the world's first atomic bomb on July 16, 1945, at the Trinity Test Site in New Mexico. This test, known as the Trinity Test, marked a pivotal moment in history. The immense power unleashed by the Trinity Test sent shockwaves through the scientific community and the world. The explosion produced a mushroom cloud that rose over 7 miles into the sky, a stark visual representation of the bomb's destructive potential. The destructive potential of nuclear weapons was no longer theoretical. It was a terrifying reality. The world had entered a new era, one where the power to annihilate entire cities was within human grasp. Despite the ethical dilemmas surrounding the use of such devastating weapons, the United States, under President Harry S. Truman, made the fateful decision to drop atomic bombs on the Japanese cities of Hiroshima and Nagasaki in August 1945. This decision was influenced by the desire to bring a swift end to the war and to avoid a potentially costly invasion of Japan. The bombings resulted in the deaths of over 200,000 people, mostly civilians, and left an indelible mark on the human psyche. The cities of Hiroshima and Nagasaki were reduced to rubble, and the survivors faced long-term health effects from radiation exposure. The horror of these events serves as a grim reminder of the devastating power of nuclear weapons and the profound responsibility that comes with their creation and use. The end of World War II marked the beginning of a new era, the Cold War. This period was defined by a global struggle for power and influence, as the world was divided into two opposing camps, the United States and its allies on one side, and the Soviet Union and its satellite states on the other. This geopolitical rivalry between the United States and the Soviet Union was characterized by an intense arms race, where each side sought to outdo the other in terms of military capability and technological advancements. With both superpowers vying for nuclear superiority, the world witnessed the rapid development and deployment of increasingly powerful and sophisticated weapons systems. The development of thermonuclear weapons, far more powerful than the atomic bombs dropped on Japan, further escalated tensions. These weapons had the potential to cause unprecedented destruction, making the stakes of the Cold War even higher. Fueled by mutual suspicion and ideological differences, the US and the Soviet Union amassed vast nuclear arsenals capable of annihilating each other many times over. The sheer scale of these stockpiles was a testament to the paranoia and fear that defined this era. The doctrine of mutually assured destruction, MAD, became the grim reality of the Cold War, ensuring that any nuclear conflict would result in the total annihilation of both the attacker and the defender. With both sides deterred from launching a first strike by the knowledge that retaliation would be swift and devastating, the world lived under the constant threat of nuclear war. The Cuban Missile Crisis of 1962 brought the world to the brink of nuclear war. This confrontation was the closest the Cold War came to escalating into a full-scale nuclear conflict. The Soviet Union's decision to deploy nuclear missiles in Cuba, just 90 miles from the US mainland, triggered a tense 13-day standoff between the two superpowers. The world watched in fear as the possibility of a nuclear exchange loomed large. President John F. Kennedy and Soviet Premier Nikita Khrushchev engaged in a high-stakes game of brinksmanship, each side testing the other's resolve while trying to avoid a catastrophic war. With the fate of the world hanging in the balance, the Cuban Missile Crisis ultimately ended with a negotiated settlement, but it left an indelible mark on history as a stark reminder of the dangers of nuclear brinkmanship. Section 4. India's entry into the nuclear club. India, a newly independent nation in the aftermath of World War II, viewed nuclear weapons as both a source of prestige and a deterrent against its regional rivals, particularly China. India's nuclear ambitions were evident from the early days of its independence, with physicist Homi J. Bhabha playing a key role in establishing the country's atomic energy program. In 1974, India conducted its first nuclear test, codenamed Smiling Buddha, at Pokhran, in the Rajasthan desert. The test, which India claimed was for peaceful purposes, sent shockwaves through the international community and drew condemnation from many countries, including the United States. India's nuclear test had significant implications for South Asia, as it upset the regional balance of power and triggered a nuclear arms race with Pakistan. Pakistan, which had fought a bitter war with India in 1971, viewed India's nuclear capabilities as a direct threat to its security. Section 5. Pakistan's nuclear program and the quest for parity. Pakistan's pursuit of nuclear weapons was driven by a deep sense of insecurity and a determination to achieve strategic parity with India. Following India's nuclear test in 1974, Pakistan's Prime Minister Zulfikar Ali Bhutto vowed that his country would eat grass if necessary to acquire nuclear weapons. Under the leadership of theoretical physicist A.Q. Khan, Pakistan embarked on a clandestine program to develop nuclear weapons. Khan's network of suppliers, operating outside of international safeguards, provided Pakistan with the technology and materials needed to enrich uranium and develop nuclear warheads. In May 1998, just weeks after India conducted a series of nuclear tests, Pakistan responded with its own nuclear tests at Chagai, in the Balochistan province. The tests, which Pakistan claimed were in response to India's nuclear ambitions, cemented Pakistan's status as the world's seventh nuclear-armed state. Section 6. The Kargil War, a nuclear flashpoint. The Kargil War of 1999 brought India and Pakistan perilously close to nuclear conflict. The conflict began when Pakistani troops infiltrated across the line of control, the de facto border dividing Indian-administered Kashmir from Pakistan-administered Kashmir. The intrusion sparked intense fighting between Indian and Pakistani forces, with both sides suffering heavy casualties. The conflict also raised fears of a wider war, particularly as both countries had recently conducted nuclear tests. The Kargil War highlighted the dangers of nuclear brinkmanship and the risks posed by the unresolved Kashmir dispute. The conflict also underscored the need for effective communication channels and confidence-building measures between India and Pakistan to prevent future crises. Under the influence of RSS ideology, Indian Prime Minister Narendra Modi has taken a politically motivated stance ahead of the upcoming elections. In the aftermath of the tragic Pulwama incident in Kashmir, where 27 individuals were killed by unidentified militants, the Modi government hastily blamed Pakistan within hours, without any substantial investigation. Despite Pakistan offering full cooperation, including a joint investigation under the supervision of a third country, the Modi administration rejected all international appeals for a transparent inquiry. This refusal further highlights the politicization of a national security tragedy and indicates a deliberate attempt to exploit the incident for electoral advantage. The incident brought nuclear tensions to the forefront once again, reminding the world of the fragile peace that exists between these two nuclear-armed neighbors. The politicization of such critical issues not only undermines regional stability, but also risks pushing the subcontinent closer to the brink of nuclear conflict. As the world watches closely, the importance of responsible leadership and diplomatic engagement becomes ever more crucial. The Pulwama incident serves as a stark reminder of how easily political agendas can exacerbate existing tensions and how vital it is to navigate these treacherous waters with care, wisdom, and a commitment to peace.